earlier dry heat. So we can use, we use 15 Pascal to create 121 centigrade. 15 minutes will be enough. 126, 10 minutes. 134, 3 minutes will be enough. So I think you remember what the Boyle's equation. When the pressure rises, boiling temperature also rises. Here we are using water, boiling water. There are types of autoclaves, but concept is almost what we would understand is, so we use moist. Downward displacement, positive pressure displacement, negative pressure displacement, and triple vacuum autoclaves. Just read, here is steam introduced into purge out air and boil pressure, gravity displacement. Other conditions are same. Here, air is first vacuumed out and then steam is introduced. High vacuum autoclave, that's it. Low temperature sterilization, here we use mixture of steam and formaldehyde vapor. That's why it's low temperature. And formaldehyde, I think you know it's a high level disinfectant. About the ethylene oxide, used for heat or moist sensitive items like syringe, other catheter devices. Prevents normal cellular metabolism and replication. Hydrogen peroxide gas plasma, nowadays it's used. It's in a fourth state of matter, liquid, gas, solid, and fourth state is plasma. Here we produce state of plasma state, and here hydrogen peroxide gas and plasma state. So it's highly reactive and act very promptly in the low temperature. So there are dedicated instrument for that, and we use catheters, catheter for sterilization. Fumigation. There are methods for rooms contaminated with some pathogen. Imagine in the theater, surgical theater, highly dedicated orthopedic theater as well as cardiothoracic theaters. If we implant while on surgery, kind of any organism, surgery will be in vain. So release of hydrogen peroxide, chlorine dioxide gases, or possibly ozone is sealed in the seal room we use for the sterilization. Now we, in the bit of low part, is pasteurization and boil. We can't achieve sterilization by means of both technique. We cannot. Semi-critical items can be pasteurized. That is, it requires high-level disinfection. Usual temperature is 65 to 77, 30 minutes. Respiratory equipments we can use, but it's rarely used. Filtration, another mode. Removal of microbes from air or heat-sensitive liquids. Disinfectant impregnant filters may inactivate trapped microbes. One example is high-efficiency particulate air, HEPA filters. It's used in type 2, type 3 biosafety cabinets. Air filters must be checked for integrity and replaced as necessary. That's the maintenance. Ultraviolet light, UV light. You know it forms chemical-free disinfectant and it penetrates organic matter and act on DNA matter and formation of different bonds and leads to disintegrity of the particular D-dimer formation and leads to destruction of microbes, mutagenic. Microwaves is rarely used. There are uses. Wrapped or packaged instruments sets in autoclave. Just to idea temperature, pressure, light pressure. So instrument wrap is very much important. Wet packs. These are practical solutions, practical part. Steroids of sterile items also very much important because we have done this sterilization. Now we have to assure this sterilization until use. Even yes. So we have to label, we have to keep them in a dedicated space, likewise. So there are ways to check about even though we are dealing with the machines, so we don't know always it's happening in the autoclave. We always, pressure may be there, even temperature indicator is there, but we don't know how this machine is working. So monitoring is must. quality assurance. So we use tapes, external indicator, autoclave tape, COVID tape we use. And once it's proper temperature achieved for the proper duration, color change will be there. There are chemical internal indicators as well. So biological monitoring system also available. For hot air one, we use bacillus substrates. Clostridium tetanus. These organisms can survive in higher temperatures. Once that particular temperature is exceeded, this biological control or this particular vial contained microbes will kill. So we use spores, keep in a particular container, and we put in the hot air oven, and we put set the particular temperature, and we keep, imagine 180 for 1 hour. Then we get them out and cut this vial and chop this off. Then we put into a culture media. If there is a growth, what does it mean? It means those organisms or spores will survive. So will it achieve the sterilization? No. So it is a biological monitoring system. For the autoclave, it's 112 like temperature, they can survive 12 minutes. Bacillus thermophilus. Filtration, they are Serratia marsensis, Pseudomonas diminuta. Ionization radiation, Bacillus cumilis. Those are the biological indicators. Asepsis of surgical theaters. What I mentioned earlier, that's all. Biopsy specimens, what we have to do. So it should be kept in study temperature in equal. Likewise, we can use this. Instruments. Sharp instruments are ideally sterilized by this application. Conventional hot air or otherwise use autoclaves. Suture material. We can use ethylene oxide, likewise, or gamma radiation. Implants with the gamma radiation we can use. Thank you.